Hi, welcome back. In this section, we're going to learn about pulse pressure and mean arterial pressure. So when we look at blood pressures, we look at what's happening in the ventricle. It creates a tremendous amount of pressure in order to eject the blood, and then it goes almost but not all the way back down to zero. In the aorta and other elastic arteries, and especially the brachial artery, which we are measuring our blood pressure in normally with a cuff, in the adult, we would have a normal systolic blood pressure of just under 120 and a diastolic blood pressure of under 80. And so the difference between the systolic and diastolic blood pressures, it is known as the pulse pressure. And so it's just simple arithmetic, do a subtraction. Now there are factors that affect the pulse pressure. The first of these is stroke volume. If we increase the volume because, like for instance, we have increased the preload or we're increasing the contractility, both of these will increase the pressure on the blood vessel outside of the heart, thereby increasing the systolic blood pressure. In addition, we look at the blood vessels themselves and what kind of arterial compliance do we have, measured in things like systemic vascular resistance. So with hardening of the arteries, atherosclerosis, we would have less compliance, thereby giving us an increase in systolic blood pressure. So if we kept the diastolic blood pressures the same and increase the systolic blood pressure, as you can imagine, the pulse pressure would increase, or what we call widen. So we can widen the pulse pressure by either keeping the diastolic the same and increasing the systolic, or keeping the systolic the same and lowering the diastolic. So go ahead and fill out these two blanks. What has to happen to stroke volume or systemic vascular resistance to increase your pulse pressure? And then the converse, in order to get a narrow pulse pressure, for starting with here, if we keep the diastolic the same and we lower the systolic, that gives us a narrower one. Or if we keep systolic the same and raise the diastolic, we would have a narrow pulse pressure. So once again, there's two lines for you to stop this and fill out. Okay, now that you understand pulse pressure, let's talk about what the mean arterial pressure. And for this, what we're referring to, what is the average driving force of blood throughout the cardiac cycle? So a lot of students think the driving force is the systolic pressure. The higher the systolic, the more force we have behind it, because yes, more force must be generated to get it out of the heart. However, it can't be this normal math thing where we take the systolic pressure and we add the diastolic pressure, add those two numbers together, divide by 2, and now we have our arithmetic mean or our average, because the heart is not 50% of the time in systole and 50% of the time in diastole. So doing this calculation for mean arterial pressure is not just one more thing for you to learn how to do. This is something that's used all the time clinically, because this is the best indicator of tissue perfusion. Systolic is just telling you how much is arriving during systole, and it gives you no clue how much is still left there until the next systole. Whereas the mean arterial pressure gives you the average force in that organ for the entire cardiac cycle. So since the heart spends twice as long in diastole as it does in systole, after all, it's lub-dub pause, then to calculate the mean arterial pressure, we take 1/3 of the systolic blood pressure and we add it to 2/3 of the diastolic pressure. So that's one way to calculate it. The other way to calculate it is to take the systolic blood pressure, add twice the diastolic blood pressure to that, and divide the entire thing by 3. And the third way is to first calculate the pulse pressure, and then the mean arterial pressure is the diastolic blood pressure plus 1/3 of the pulse pressure. So 3 different ways of calculating mean arterial pressure. So I want to thank you for this portion. I want you to realize there's only one more video in our cardiovascular physiology section. So I want to thank you for sticking with it. If you need more practice calculating pulse pressures and mean arterial pressures, look at some of your lab material and just redo those numbers. And I see you shortly.